Let me welcome you to the ninth lecture of NPTEL online certification course underground mining of metalliferous deposits. We are in the introduction of the course and in which we are determining the cutoff grade. This is the third lecture on the cutoff grade determination, and in previous lecture we are calculating the cost required for different mining process, so that we can find out the economic analysis or economically what could be the cutoff grade for having the no profit no loss condition for that particular mineral percentage. Now, before start, let us have one glimpse of the learning background required for the participants of this course. These are the learning objectives and these are the expected learning outcomes from the participants of the course, and these are some of the text and reference books for the additional reading from participant side. And this is the objective of this lecture. We are already covered the what is cutoff grade definition. We have already learned the material flow, and we are now carrying out the financial appraisal, how to calculate the cutoff grade, and we are exercising the determination of cutoff grade as we are calculating now the cost analysis. So, let us directly go into our cost analysis part. We have already carried out the cost analysis. What is the return? This is the return we found from 1 ton of ROM. Last class we have already calculated. This is the direct mining cost, this is the depreciation. These are already calculated in the last class, and after that we are following the process. So, as the following process is that ROM to the mill, to the smelter and to the refinery. So, the mining cost in this together here is $4.37, depreciation is $0.87, and we have seen the transportation cost from here to here is 0.03, and the smelting cost here is $1.10. So, up to this we have already calculated. Now, the next part is that we have to send the material from the smelter to the refinery, and for sending this material from the smelter to the refinery, the assumed cost is $50 per ton of copper in blister copper. So, this is the $50 per short ton of copper available in blister copper, that is the output of the smelter. So, whatever is the output of the smelter, again I am telling you it is not important, it is the copper percentage of that blister copper is important. So, we have seen it is a ton of copper available in the blister copper, and you know that ton of copper available in blister copper is basically representing 233.1 ton of ROM. So, if we place 233.1 ton of ROM, from there we will get 1 ton of copper available in the smelter output at this position. So, the transportation cost is $50 divided by 233.1 ton, that is the transportation cost from smelter to refinery. So, it is coming close to $0.21. So, the transportation cost is $0.21 from smelter to refinery for 1 ton of ROM. So, all this cost calculation we are carrying out to see what is their impact on processing of 1 ton of ROM. So, this is the transportation cost for 1 ton of ROM. Now, from 1 ton of ROM, whatever we are getting here is 8.58 pound of copper is basically coming here, and refining cost is given as $130 per ton of copper in the blister. So, we know that per ton of copper in the blister is basically representing 233.1 ton of ROM. So, the refining cost is $130 divided by 233.1. So, it is coming 0.56 dollar as the refining cost. So, the refining cost is 0.56 dollar is the refining cost. So, now let us compute all this expenditure in a one tabulated form. So, you can see these are the mining and milling cost, this is depreciation, this is transportation cost from mill to smelter, this is smelting cost, this is transportation cost from the smelter to refinery, this is refining cost. But after the production of the pure copper in the refinery, we have to finally send that in the market. So, the final shipment cost, it is considered as the $0.01 per pound of pure copper is considered as the transportation cost, and that means our from 1 ton of ROM, we get a pure copper of 8.56 pound, and £56. So, the final transportation cost of that copper to the market is 8.56 into 0.01. So, it is closely coming $0.09. So, this $0.09 is the transportation cost of the pure copper from the refinery to the market. So, if we are looking at our material flow processing, so this is consumer, this is mine, mill, smelter, refinery. Now, here we are producing 1 ton of ROM, and after this we are sending from refinery, we are sending the material to the consumer, that cost is 0.09, that is incorporated here. And finally, we have considered some other cost associated in smelter and refinery, just like the overhead cost we have considered at this is as the 0.07 pound per ton of pure copper. So, with this assumptions, as our pure copper has come out this one, there is a total cost assumed as the other cost or general and administration cost in the refinery and smelter as the $0.07 per pound of blister pure copper. So, with the considerations it is coming 0.07 multiplied by 8.56. This 8.56 has come from 1 ton of ROM. So, this is from 1 ton of ROM, this has come out. So, the total cost is coming $0.06. So, in altogether if we are calculating all the cost, then the total expenditure, that means with summing up of this one, this one, this one, this one, this one, all this. So, depreciation, direct cost, depreciation, mill to smelter, smelting cost, smelter to refinery, refinery cost, final shipment and general cost at plant. In all those considerations, the total expenditure has come $7.83 for 1 ton of ROM, that is for 1 ton of ROM, or you can say 8.56 pound of pure copper product. So, from 1 ton of ROM we get 0.56 pound of copper and the total expenditure incurred for that is 0.7.83. Now, what is our income? Income is 10.33, cost is 7.83. This shows there is a profit of $2.5 is profit by mining of 1 ton of ROM. So, if we are carrying out mining 1 per ton of ROM, we have a profit of $2.5 if we are carrying out mining of 0.55 grade of copper. So, 0.55% of copper, if we are carrying out mining, that mining gives us $2.50 profit. But the problem is, if we have calculated this one, we do not know what is the grade at which the net value will be 0, because our cutoff grade means is the grade at which there is no profit, no loss condition, because mining of that will eventually reduce the profit. So, that is why we want to find out economically which one is basically accepted for us. So, the general technique is that we have to calculate this for different grades of ore and we have to find out where the net value is becoming 0, or we can find out the trend, and extending the trend we can find out at what net what percentage of copper or grade of the mineral the net value is becoming 0. So, for this, in a very simplistic manner, another analysis is carried out with the grade of 0.35. So, the analysis is same. First let us look into the analysis, then we will go into this. So, the assumptions are all same. It is based on the short ton, and let us start the calculation of this one, then we will gradually wherever the differences are there, we will discuss that one. So, now we understand that it is a 0.35% copper. In 1 short ton, the copper is 7 pound only, and we consider the mill recovery remains same, that is 80%, that 80% copper is recovered in the mill, and the mill concentrate is also, it is 20% copper in the mill concentrate. Now, this is our assumption. In a realistic case, the moment you will change the grade, obviously there is an effect of the mill recovery, there is an effect on the mill concentration also. So, that copper concentration in the concentrate also. So, that is why this is in realistic case, when this has to be carried out, the actual output in the practical cases or in the previous history what is obtained practically must be considered, but there in theoretically we are considering that the recovery and concentration both are basically same with respect to the grade, but this is not a realistic assumption, in that there are some effect and that will be changed, but theoretically let us consider it is same. Considering this 80% recovery, we will find out in the mill concentrate we are having 5.6 pound, because 80% is recovered only. So, the 5.6 pound of copper is there in the mill concentrate, and similarly we can find out that we need 71.43 ton of ROM to have 400 pound of copper in the concentrate, or in other words 1 ton of mill concentrate can be generated from 71.43 ton of ROM. So, that means if we are having mine here, we have, if we send 1 ton of ROM with 0.35% Cu, we will get 28 pound of concentrate with 5.6 pound of copper after the mill. So, this is we have calculated here 28, and we also found that 71.43 ton of ROM is required to generate 1 ton of concentrate, which we will use in our next calculation. Now, let us see what is the smelting loss. If we see the smelting loss, again we assume it remains same, because we have assumed the concentration is same. So, as the concentration is considered same, that is why our smelter is also behaving properly onto that. And now, in smelter we have found that 10 pound of copper is lost per short ton of the concentrate, and you understand per short ton of concentrate means it is 71.43 tons of ROM. So, that is why this short ton is cancelled. This is 10 by 71.43. That means, if we are sending 1 ton of ROM, then we will get, there is a smelting loss of 0.14 pound of copper into that. So, our 5.6 pound was there in the concentrate after the mill. In smelting it is lost 0.14 pound. So, our after smelting whatever blister copper is produced, this much pound of copper is available in that blister copper, which is generated from 1 ton of ROM. So, this is our calculation, or in other word we can see this is the calculation we can consider in this case. Now, let us look into what is happening to the refinery. Refinery, again it is told that there is a loss of 5 pound of copper per ton of copper in the blister copper. So, loss is 5 pound of copper is lost per 2000 pound of copper in blister copper, or you can say the smelter output. So, in consideration to that, we know in our 1 short ton of ROM we have 5.46 pound of copper. So, after the smelting, that means in the blister copper we have 5.46 pound of copper from 1 ton of ROM. So, in blister copper, to get 1 ton of copper we need 366.3 tons of ROM. So, that is why this 2000 divided by 5.46 is basically gives us 366.3. that much tonnage of ROM is required to get a 2000 pound of copper in the blister copper. So, that means this is the refinery. So, this is ROM. If we send 1 ton of ROM, this is smelter and this is refinery. Now, if we are sending 1 ton which is having 7 pound copper, it is becoming 5.6 pound copper here and 28 pound concentrate here. Here it is further reduced to 5.46 pound, and we are now calculating this one, and we have found that for getting 1 ton of concentrate we have to provide 71.43 pound, and to getting 1 ton of blister copper we have to provide 363 tons of 363.3 tons of ROM here, and from there I will get 1995 pounds because of 5 pound loss. So, there is a smelting loss of this much per ton of ROM, and by reducing this one we will get 8.45 pound of copper as the final product. So, after refining we will get 8.45 sorry 5.45 pound of pure copper will be obtained after the refining of the blister copper of 5.46 pound. So, blister copper content in the blister copper of 5.46 pound. So, there is a 0.01 pound of copper will be lost in this process. So, now let us look into the cost calculation. We have considered the cost price is same, but there is a little bit of reduction. There is a little bit of reduction in the byproduct. So, byproduct is basically the return from the byproduct is basically reduced in proportionate manner. That means, in earlier case 1.77 was from 0.55. Now, in 0.55 this is our return. So, in 0.35 our return is x into 0.35 divided by 0.55. So, in this proportionate matter the byproduct return is considered, and here it is considered as $1.13, and this 5.45 is the final copper produced from 1 ton of ROM, multiplied by this plus this is coming, return is as the $6.58 is the return by selling this copper of 0.35. Now, let us assume the mining cost. Again we have considered all the mining costs same. So, the mining cost has direct production cost has come in mines and mills is 4.36 $0.37. Again the depreciation is also same. So, the depreciation and both are considered in a similar manner, and this is the direct costs. Now, let us see the calculations for the transportation cost from the mine to mill, from the mill to smelter. So, this transportation cost is assumed in the same rate, and now if we are converting it into the ton of run of mines, you can see 1 ton of concentrate is coming out from 71.43 ton of run of mines. So, by converting this to per ton of run of mines, we have found this is $0.02 is the transportation cost. So, $0.02 is the mill to smelter transportation cost is considered. Then smelting cost, again we have considered the same rate, and this again it is converted to the 71.43 ton of ROM. So, 50 by 71.43, that is coming 0.70 is the smelting cost dollar. Similarly, the transportation cost from the refinery smelter to refinery is considered, which is based on the ton per ton of copper in the blister copper, and we know per ton of copper in the blister copper is obtained, 1 ton of copper in the blister copper is obtained from 363.3 ton of ROM. So, we are converting this 50 by 366.3. So, that is coming $0.14, and in similar way refining cost is coming 130 by 366.3. So, that is coming around 0.35. So, we have computed this in the cost table 0.35 and 0.14. Now, the final shipment cost, again this is based on the pure copper. Our pure copper is from 1 ton of ROM is 5.445. So, this is 0.05 is the final shipment cost, and the other cost, that means the general and administrative cost, again we have considered based on the copper, that is $0.07 per ton per pound of copper, or in 1 ton of ROM how much copper we are getting. So, based on that it is coming 0.038. So, altogether the total cost is coming around 6.88 dollar, which is nothing but the adding of direct production cost, depreciation, mill to smelter transportation cost, smelting cost at smelter, smelter to refinery transportation cost, refining cost at the refinery, and final shipment cost, that is the refinery to the consumer, and general cost at plant and refinery smelter. These are considered, and considering this the total expenditure has come out this. Now, if we are considering this, our profit or income from selling that was $6.58, but expenditure is $6.88. So, there is a loss of $0.3 by mining of 0.35, sorry, this is 0.35 percentage of copper in the ore. Now, if we are plotting these in a graph, then what we are finding, this is ore grade, this is ore grade, and this is the net value. Net value means income minus expenditure, and in consideration of that, by plotting this point for 0.55 grade, we are having a $2.5 profit. For plotting the 0.35 grade, we have a loss of 0.3. So, if we draw a straight line of this point is coming, which is 0.37. So, this 0.37 can be considered as the cut-off grade, which is basically gives us the no profit, no loss condition. So, this is a very simplistic assumptions where we have considered all the values are remaining same. The change in the grade is not basically affecting the performance in the mill, though it is not actual case, but generally the actual practice has to be adopted, and in that case there may be a number of intermediate point also. So, if we are plotting this, which it may comes like this, whichever it is, or maybe coming a little bit like this also. So, based on that condition, whatever value is basically obtaining at this 0 net value, that is considered as the cutoff grade. One thing is very important here to consider, that cutoff grade is the grade below which we do not mine, because it is basically leading us to a loss. But if we are carrying out mining in the cutoff grade, it is not gives us the profit also. So, average grade of mining is always significantly higher than the cutoff grade, so that we can have a good profit in the process. Otherwise, only carrying out mining in the cutoff grade will not give us a profit. So, cutoff grade is the grade which has to be followed, that below which the material should not be sent to the further processing, because it is incurred a loss in the total system. But one thing is very important here, that if what will happen to the value of those ores, what will happen to the value of those minerals which has a grade lesser than the cutoff grade. Basically, those are considered as the potential ore, because with the current technology that ore is not profitable in mining. That is why we considered it is below cutoff grade and we are not carrying out mining. But it may be possible in the future, our milling technology is changed, or refining technology is changed, or maybe the mining technology is changed. So, that $1 per ton we are considered in the mining, that may be become to $0.8 per ton. In that case, we can fetch a profit in the system. So, the grade below the cutoff grade is considered as a potential ore for the future consideration, and that can be adopted in a future condition. And it also may be possible if the value of the copper is increased. In that case also, it is possible that the total system can fetch us some profit. So, that must be also considered in those cases. So, let us stop at this position. Thank you.